All right, here goes. So now that we've talked about radical expressions, there's something related to them, kind of just a different way to write our radical expressions. And that is using what's called a rational exponent. Now remember the word rational just means a fraction. Okay, that's the fancy math word for fraction. Okay, so we're talking about exponents that are fractions. Now, if you remember in this class, way back chapter, I think it was 4, I think it was section 4.1, we talked about negative exponents. So something I mainly assume about you coming into this class is you understand how to work with exponents, but we reviewed that. We reviewed the product rule, quotient rule, and we'll review them real quick again today. And then negative exponents, we talked about in chapter 4. Negative exponents, remember, told you the base was in the wrong place. And so now we're just expanding our knowledge of exponents a little bit to exponents that are fractions. And so when you have a fractional exponent, like in my first example, I've got 9 to the 1/2 power. That fraction is telling you something specific. And so you'll notice the first few examples we do, the numerator of the fraction is 1. Because the really new part of this is, what is the denominator telling me? So this denominator, this 2, what it is telling me is it's telling me the index of the radical. See, fractional or rational exponents is just another way to communicate a radical. So this problem right here, when you see 9 to the 1/2 power, what that's really saying, I'm going to put the 2 in the basket on this one just so that for your notes you see where it went to. I've got the square root of 9. Just another way to write the same thing. After you've done enough of them, you don't have to write the radical out, but I would expect in this class, you're probably not going to do that many, but once you get used to the math language. So then the square root of 9, we know that as 3, okay? No big deal there. So we're going to take this one at a time because the main thing is I want you to get used to the notation. So go ahead and do exercise 1 right next door, okay? Why don't you make that into a radical first? Let's practice that and then evaluate what the value is. All right, what did you write as the equivalent of 81 to the 1/2? You're a step ahead. What's the radical expression that's related to this? Okay, the sign's called a radical, but you're totally right. I'm not going to put the 2 in the basket this time because I don't tend to. But if you do, it's not wrong. Like I said, different parts of the world put 2 in there for a square root. So I did on the first one just for your notes so you know where it went to. So I got the square root of 81, that's for sure. And the square root of 81 is 9. Okay. So far, so good. We doing okay? We're going to practice this a few more times, and then I'm going to talk about what happens when there's a numerator that's not 1 up there. What do we do with that? Okay, so next, go ahead and do exercise 2. 125 to the 1/3 power. Okay, so what did you write first as the radical expression that's related to 125 to the 1/3 power? It becomes what? Cube root, 3 in the basket. Yes, 3 radical 125. And then what is the cube root of 125? It is perfect. You're doing great. All right, do exercise 3. Be careful of those parentheses and what they're communicating to you. And if you don't know, make a hypothesis and we'll check it. We'll see if you're right or wrong. Right, so we just saw in the previous exercise that the 1/3 power means a cube root. So what am I taking the cube root of in this problem? Yeah, the -27. So in case you forgot this, that's okay. That's why I review these things. So make sure you take note of this. The exponent applies to whatever's right below it. And what's right below this 1/3 is the parentheses. Okay, so this parentheses is right below the 1/3. So that means when I take my cube root, it's the cube root of -27. We'll see this coming up in a little while, but if I had written the problem like this, I'm going to come over to the side before I finish up. I'm not done with exercise 3, but if I had written the problem like this, -27 to the 1/3, like this, in that case, what am I taking the cube root of? Just the 27. Okay, so this one would be a negative out in front of the cube root of 27. So please notice the difference. Parentheses are communicating something important to us, okay, about what our grouping is and what we're taking the radical of in this case. So back to my original example, the cube root of -27 is equal to -3. We saw that on our previous page in section 7.1. Okay, just one more, and then I'm going to tell you what the numerator is. So go ahead and on the next line, do exercise 4. All right, so 625 to the 1/4 power, that means what's the index of my radical going to be this time? A 4. Okay. The index is a 4, so it's the 4th root of 625, so like that. And then again, numerically, we saw this earlier. I don't think there's too big of a mystery here. What number times itself 4 times is 625? It's going to be 5. Okay, so my next example is right next door. Now, instead of 9 to the 1/2, in my next example, I have 9 to the 3/2 power. Okay, so we know, and this does not change, that the 2 right there, that's the index. Okay, that we've reinforced that with several examples. And now this 3 right here, this 3 remains the exponent. Now you could write this in one of two ways, but I'll tell you which way is more common and which one's more beneficial to you for the work that we will do in this class. So what we'll do is we'll say this, okay, I've got since the index is 2, I've got the square root of 9, and then I'm going to put a parenthesis around it, and I've got cubed. Now that's the way that I will tend to write this. You could, and it's fine, but it's in the case of the examples I have for us to work, it's not as easy to work. Or you could say it's the square root of 9 cubed. You could put the exponent under that. Either way, order does not matter as far as your radical and your exponent. But I find it a little more difficult to do 9 to the 3rd in my head. I think it's 729, but I'm not positive. Okay, and then take the square root of that. The numbers just get too big. So what I'm going to do is do it in the first way on the left here. Square root of 9 is 3. And then 3 to the 3rd is equal to 27. So I will be doing the radical inside the parentheses and then putting the exponent outside around it. Any question about what I did there, where the numbers go? Well, let's see. Try exercise 5. Next line, first problem on the left. Okay, which one of those numbers, the 2 or the 5, represents the index of my radical? The 5 does. Thank you. Appreciate the confidence. And you're totally right. So I've got the 5th root of 32, and then I'm going to raise that all to the 2nd power. 5th root of 32, that we've seen that before. That's 2. So I've got 2 to the 2nd power, and then 2 to the 2nd power is equal to 4. There we go. If you got a question about that, please ask it. We're going to do several more just because we're getting used to what I'm assuming for most of you is a new concept. Exercise 6, do 8 to the 5/3, please. All right, so in this problem, the 5 or the 3, which one of those is? The 3 is, so I've got the 3rd root of 8, and then I'm going to raise that entire thing to the 5th power. And so the 3rd root of 8 is 2, so I have 2 to the 5th, and 2 times 2 times 2 times 2 times 2 is 32. Anybody get something different that we need to talk about? All right, the next line. The next 2 problems, we're going to deal with negatives and parentheses and making sure you got that sorted out. So again, more opportunities for questions. So on exercise 7, what is going to be the index of my radical? 2. Okay, so here is my square root, my radical with a 2 in the index. Now, before I write anything else down, what am I taking the square root of there? Okay, not the negative, the 100. And so then I'm going to put the cubed around that. And that negative, there's no parentheses, that negative is outside, not till I'm done with everything else. Okay, so far outside. Again, the reason for that is the exponent applies what's directly below it to the left, which is just the 100, not the negative, just the 100. So then the square root of 100 is 10, so I get negative 10 cubed, and then 10, again, it's not, don't worry about the negative, the 10 cubed, 10 times 10 times 10 is 1,000, and then that negative finally makes it negative 1,000. In a similar way, do exercise 8 right next door. So I'm pretty sure you'll tell me on this one that the index of the radical is a 3. It's a cube root on this problem. On this one, what am I taking the cube root of? Yeah, the negative goes with it because of those parentheses, the negative 125, and then I will square that whole thing. So the cube root of negative 125 is negative 5, and then I'm squaring that. So negative 5 times negative 5 is 25. The last 2 problems on the front of this involve negative exponents and recalling what those were. And I mentioned it earlier. A negative exponent, this was in chapter 4 when we were way back in the 2nd unit of this class. Negative exponents tell you the base is in the wrong place. So see what you can do with exercise 9. And if you don't get it, that's okay. You're going to get your chance on exercise 10. Okay, so what I'm going to do first is I'm going to resolve that negative exponent. Okay, that's what you should do first. Don't do anything until that negative exponent is simplified. Okay, so that means what I'm going to do first is I'm going to say, oh, that negative means that instead of being in the numerator, this 1,000 should be in the denominator. So this is 1 over 1,000 to the 2/3. Okay, that's step 1. Now, again, I know it's been a while, but that was something we've talked about before. Okay, it's good review for the final. That concept is on the final, a negative exponent. Okay, and then in the denominator now, I just do what I've been doing with the other problems with the 1,000 to the 2/3. So I'm going to have the cube root of 1,000 squared, and that's in the denominator because of that negative exponent. The cube root of 1,000, what times itself 3 times is 1,000? Well, we've seen already that's 10. So I have 1 over 10 squared in the denominator. And then 10 squared, 10 times 10 is 100. All right, so I know it's been a while since we saw a negative exponent, so I get it. If you goof that up, no big deal. Forgive yourself. No shame. Now try exercise 10 and get it right this time. All right, so again, the first thing I'm going to do on this problem is I'm going to resolve that negative exponent. So this negative 4/3 tells me I've got 1 over -8 to the 4/3 power. Hey, notice when I changed my fraction, nothing happened to the negative in front of the 8. That's just a negative value. Only the negative exponent matters as far as flipping the base. So now what I've got is I've got 1 over, I've got a cube root of -8, and I'm going to raise that to the 4th power. The reason the -8 is under the radical is because there was parentheses around that whole thing. So now I have the cube root of -8 is -2 raised to the 4th power. And when you raise -2 to the 4th power, you get +16. So the answer there is +16. So in those examples, I tried to think of every different permutation of what you're going to see when you go through your homework. So let's flip the page. And again, okay, so just to remind you, okay, you're going to do every one of these exercises at some point, but I just want to remind you real quick of the properties. We talked about these long ago, and the properties don't change because of the fractions. So just real quick, just because I know it's probably not top of mind, the product rule. The product rule for exponents says this, and I'm just gonna make up a real quick example. There's gonna be one of each. If I have x to the 5th power times x to the 7th power, what do I do with those exponents when I'm multiplying the bases? Yeah, add them. Okay, that's gonna be the same no matter what. So this is x to the 5 plus 7 or 12. The quotient rule. That you are totally 100% right. So if I make up a quotient rule problem, let's say I have x to the 8th divided by x to the 4th. Okay. Well, now you subtract the exponents. So 8 minus 4 is 4. And remember, if you ever get a negative exponent out of that, you resolve that negative like we did on the previous problems. And then finally, the power rule says what happens when I have a power to a power. So if I have x to the 4th raised to the 8th power, so I've got a power raised directly to another power. What is that equal to? What do? You multiply. It's x to the 32nd power. Fantastic. Okay, so we're just going to do these one at a time because I know that some of this we're going to have to real quick review how to do these operations with fractions. Okay, so exercise 11. Give exercise 11 a try. You got 2 to the 1/5 times 2 to the 2/5. So I'm just going to go around on the side here on some nice scratch work. So you just told me a second ago when I'm multiplying the bases, I add the exponents. So I'm just going to come over here and say, okay, if I have 1/5 plus 2/5, and we just spent a chapter talking about fractions, but I know when there's numbers there, it freaks us out a little bit. What is my process when I'm adding fractions? What do I have to have? Same denominator, which I do here. And when I have the same denominator, what do I do with the numerators? Just add them. So this one's nice, easy. I gave you the common denominator just to warm us up. So I've got 2 to the 3/5 power. So far, so good. We 1 for 1. All right, well, the next problem, I wasn't so kind. I've given you ones that have different denominators. So take a moment. Remember, you got to figure out the common denominator. You change your numerators, then you can add. It's the same process we just did in the last chapter. All right, so once again, I know I'm multiplying my bases. I've got to add the exponents. So I'm going to go over to the side. I'm going to do my adding on my scrap work here. So I've got 1/2 plus 1/3. I've got to add those two things. What's the common denominator between those two fractions? 6. So what do I multiply 2 by in order to get 6? How do I change this first fraction? Multiply by 3. So 3 times 1 is 3/6. And then the reverse is true. 3 times 2 gives me 6. So 1 times 2 is 2/6. So when I add those up, 3/6 plus 2/6, that becomes 5/6. That's my new exponent. So over here, I've got 7 to the 5/6 power. All right, the next one, the next two talk about our quotient rule, subtracting the exponents. So I've done the same thing here. One of them has common denominators, one doesn't, just as we are getting acclimated to this. So go ahead and do both of them. Do exercise 13 and then 14. If you have a question, if you totally are blanking on this, raise your hand. I'll come to you. right, so the first one, exercise 13. I see that I'm dividing, so I need to subtract those exponents. So I'm going to go over on my scratch work here. I'm going to say, okay, I've got 2/3 minus 7/3. Those already have the common denominator. So 2 minus 7, that's equal to -5/3. So when I divide those two things, I get 5 to the -5/3 power. But again, we don't leave negative exponents unresolved. We're going to resolve that. So that negative means the base is in the wrong place. So I have 1/5 to the 5/3 power. All right, I asked you to do both of these. So hopefully you're at least working on the second one, making some progress. So I have 5/6 and 1/10. So I'm going to subtract 5/6 and 1/10. What did you use as the common denominator between 6 and 10? 30 is the easiest thing, but remember, the little math secret is you can use any common denominator. Okay, you could use 60 if you want. If you just multiply those two things together, it will work. You'll just have a little more reducing to do than I will. So I'm going to use 30. 6 times 5 gives me 30. So 5 times 5 is 25/30. 10 times 3 is 30. So 1 times 3 is 3/30. So 25 minus 3 is 22/30. I can reduce that a little bit. I might as well just go ahead and do it. What factor goes into both 22 and 30? 2. 2 goes into 22 11 times. 2 goes into 30 15 times. There's my common denominator. Excuse me, there's my reduced fraction. So when I do this, I've done all the work. Now I just got to write the answer. When I divide those two things, I get x to the 11/15 power. All right, so the last two of our basic examples are exercise 15 and 16. They're power rule examples. Power rule, you told me earlier, means when you have a power to a power, you multiply. So give both of those a try. So I see that I've got 2/3 to the 5th power. So I'm going to multiply those. So I'm going to come over here on my scratch work. I've got 2/3. I'm multiplying by 5, which I'm going to write as 5/1. And then how do you multiply fractions? What do we just do? Tops and bottoms. Okay, so the top 2 times 5 is 10. The bottom 3 times 1 is 3. So 10/3. So this is x to the 10/3 power. Nice and straightforward and relaxed. The next one's the same thing. I just got a 5. I got a number as the base instead of a letter. So I'm going to come over my scratch work. I've got 4 to the 2/7. So I've got 4/1 times 2/7. Again, to multiply, you just go straight across tops and bottoms. So 4 times 2 is 8. 1 times 7 is 7. You get 8/7. So this is equal to 5 to the 8/7 power. All right, so we're just going to do 2 more problems today, and then we'll pause and we'll pick up the rest. But you'll have enough information after these 2 problems to be able to do your homework. But we will finish this up next time. Don't worry, I won't leave you hanging. So exercise 17, all the remainder problems do now is take the 3 basic properties and just combine them into one problem. So here's a little hint for exercise 17. I would apply the power rule at the top, get rid of those parentheses. And then you're going to have the quotient rule with the y's. And that's going to take you to the finish line. So give it a try, see how you do. Remember, opportunity to learn if you don't get something right. Do the power rule with the top, and then you're going to have your y's. You'll do the quotient rule with the y's. All right, let's see how you did on this one, and then we're going to do one more, and then we're going to call it a day. So I told you to go ahead and do the power rule in the top. Get rid of those parentheses. So here we go. I'm just going to go over to the left. I'm going to use my scrap work. So on my x, I've got 1/2 raised to the 4th power. So if you don't need to write this down, that's fine. But 1/2 times 4/1. When I go right across the top, 1 times 4 is 4. 2 times 1 is 2. And 4/2 is 2. So what I start off with, I've got x to the 2nd power. Then I've got y to the 2/3 raised to the 4. So 2/3 times 4/1. Again, go straight across the top. 2 times 4 is 8. 3 times 1 is 3. So that's 8/3. So I've got y to the 8/3 power divided by, in the bottom, I've got y. Now, in the bottom, it's just a plain old y. That's a y to what power? The 1st. Okay, when you don't see an exponent, it's the 1st. So now to finish out this problem, I've got one thing to do. The x is done. The x, I'm going to just write x squared. There's nothing else to do the x. But I've got to deal with these y's. I got to simplify this using the quotient rule. So I've got 8/3 in the top. I've got 1 in the bottom. So 8/3 minus 1. The common denominator is going to be 3. So I've got 8/3 minus 1 is how many thirds? 3/3. 3/3 is 1. Okay, 3 divided by 3 is 1. So 8/3 minus 3/3, 8 minus 3 is equal to 5/3. So I've got all my scratch work. So I've got y to the 5/3 power. There we go. All right, so last problem for the day. We'll finish the other 4 next time we see each other. So exercise 18, same sort of thing, but you just got to apply the power rule now to everything inside the parentheses. Then you'll be good to go. All right, so I'm just going to get started on this. If you're working, keep working. Okay, I'm trying to keep the numbers sort of manageable and reasonable here. So I've got my a to the 1/3 raised to the 6th. So I've got 1/3 times 6/1. So 1 times 6 is 6. 3 times 1 is 3. 6/3 is 2. So to start off with, I've got a to the 2nd power. Then I've got b to the 2/3 raised to the 6th. So that's 2/3 times 6/1. And so in the top, 2 times 6 is 12. 3 times 1 is 3. 12/3 is 4. So I've got b to the 4th power. So far, we so good? If you made a mistake, do you see your mistake? I know working with fractions is inconvenient and uncomfortable. We don't love it. Okay, but all these problems are going to work basically the same. Okay, so even though we haven't finished the section, you can get going on your homework so that you don't get behind and have a lot to do. We will finish the other 4 problems up. That's no problem. In the denominator, I've got b raised to the 6th power. No fractions involved, so that's a relief. Then the last thing I have to do, I see again, the a is done. There's no other thing with an a, but my b's, I've got to do those. So what I've got here is I've got a to the 2nd in the top, and then b to the 4th divided by b to the 6th. What's 4 minus 6? 4 minus 6 is -2. And so that negative tells me to put the b to the 2nd in the bottom. And so you get a to the 2nd over to b to the 2nd as the final answer there. All right, so that is that. And we will, like I said, finish